So we'll see the light model emission. So if we see, there are three things. One is light source. It can be many in number, only one light model. And from the light source, ambient, diffuse and specular, three component of the light comes into the picture, whereas light model add ambient. So each light source has three, where there is only one light model has ambient, and then material has these many reflection properties. So this is emission and this is reflection. Now once we see the calculation, the light received by a vertex is emission of the material, ambience of the light and ambience of the material, and then per light model. If light model is n, per light model, this is called attenuation factor, spotlight effect, and then ambience into the light and that light I, and material and diffuse of the material, and shininess of the material and the light. Specular shininess of the material and the light. So this factor adds up and make the lighting at the vertex. So now we'll see the ambience factor. So ambience of the light model, ambience of the material, and then ambience of the material and ambience of the light source. Okay, so light model has a parameter called GL light model ambient. So we'll open this file and we'll add a GL light model. Okay, so there is no GL light model. So where we should add in the init, here we'll add GL light model FV GL light model ambient. Okay, so there are many scenarios. That's what we are seeing. So this is the kind of normal scenario. Okay, so we'll make it as a kind of 0 point. Okay, so that is the lab session. So lab session, first it should come as yellow and red, and then it should come as green. Okay, so we'll make it as like this. So this is the light model ambience. And here we will add GL light FB GL light 0, GL ambient, zero, 0.2, 0, 1. So what we are doing is, here it is green and here it is red. These are the two ambience we are adding, and we'll have here pyramid and cone. So we'll add one more guy, that is cone. So light cube, pyramid and cone, and we'll have ambience like this. So light model. So I want to show that there are two ambience. One is red and one is green. As per the calculation, this ambience should also take into effect, this ambience should also. So if this is light and if this is green, so as per the formula what we had, LR into MR, LG into MG, LM, LB into MB. So with this formula, okay, this should add red component, this should add green component, And if this ambience is white, it should look yellow. That is the idea. Now we have shape equal to sphere. Now we'll have 2, 3, 4, 5, 6 yy, and we'll have shape equal to cone. Okay, front ambience is 1. Okay, so 0.5, this is what is the experiment. 0.5, 0.5, 0.5, okay, and then diffuse is, okay, so diffuse, its color is green, sphere, so it's okay. Specular is 1, shininess 40, and this is what it is. Now for the cone, it is 0.5, so this is the experiment we are doing. 0.5, 1.0, and this would be red, so cone should look red, or here it is purple, so we'll make it purple. Diffuse, specular is 1, shininess. So here we have blood, solid cone, where this I can make 0.8, 40, 32. That's it. Now we have 3 ambience. One is material ambience, and then we have light modal ambience, and this much light we won't throw now. And then we have new called light modal ambience. Now we'll practice. Okay, I think pyramid has come. This is what we don't want. Okay. Sphere. Okay, so I have now, so I can make a sphere move, right? Now I have a sphere and I have cone. So I can show the cone. There is no hesitation in there. So this is the cone. Now we can see the diffuse, that is green, diffuse is purple, and then we can see the specular and shininess, it is visible. Okay. Now we'll see the ambient is not visible here. So what we can do, so we'll show the light. So this is the light. So we'll rotate the light. Now both are yellow. Okay. So yellow would be more prominent if we increase the ambience. Okay, so we'll increase the ambience. So here 0.02, instead of that I can make 1.0 or maybe 0.4, and here also 0.4. So it would look little brighter. Okay, I think this is, we press twice, so that's fine. Now we will rotate. Now we have light source. Yellow is prominent now. So this is the ambience. So ambience is yellow. Ambience is yellow because both ambience are coming into the picture. If I comment this, no ambience from the light model. So if I comment, there will be default ambience from the light model. So I would deliberately make it 0. No ambience from the light model. Only ambience from the light source, that is red. So now ambience should be red as per the formula. Okay. So lighting has come. Now we can go. Okay, so it okay, so we can rotate now. Okay, so ambience is green. This is what we are seeing. We expected red. So let's see. So clearly it is green. Oh, it is green. Here it was red. So here it was red and here it is green. So we can make it, so ambience is green. No, it's not yellow. If I set it here 0.04, then it would come as yellow. Red and green and multiplied. So now it would be yellow. Okay, so it is yellow. If I want to make it red, leave it as red and this light source will comment. So instead of commenting it, we will make it 0, forcing it to nothing. So now it would be red. Okay, so ambience is clearly red. So this is the light model, and so we covered this in lab session. We covered the this. Now what about the ambience of light model and ambience of light source? Both as 1. So these would emit ambience 1 and this guy will have different kind of reflection. So we are proving both the things. So what we can do now is, now this we can make as white light, white dim light in ambience, and here also white dim light, and in the sphere ambience, the sphere will make red, ambience as red, and cone will make it as yellow, as green. Okay, sphere is blue and this is green. So sphere is blue, so this is blue. So sphere is blue and it is green, and both light source, this light source ambience is white and this is white. Now we can try again. Okay, so I have light source visible. I can rotate. It is quite clear that one is blue and one is green. We can make it more prominent. One also, if I increase, it should be okay. we can see that this color has also changed because ambience also comes into the picture. Okay, so it is more prominent now. One is blue and one is green. So this is the idea of ambience. So ambience has two sources. Only ambience, not others. So light source also emit ambience and light model also emit ambience. And these two ambient finally get multiplied to the material ambience, and this is what it reflects. So we don't want this big ambience, so we'll close this. We'll reduce it because accidentally it will be very big. Or we can altogether comment this because anyway it adds the default ambience. This is the default 0.02 and we'll comment this also. So this is our ambience. Now in next lab, okay, we'll see a model local viewer. So we'll cover this part anyway. Emission and ambience of light. So this is what we have seen. Ambience of light model, ambience of material per light model. Sorry, per light source. Ambience of light into ambience of material. Now, if I see ambience of color model like this, light model, light source is different, that emits the diffusive and specular, whereas light model adds ambience, but light model adds more things also. So we can set light in light model, we can set ambience. This is what we did. In light model, we can set local viewer. What is local viewer? Right now we are talking about camera is placed at 0, 0, 0. It's not. In the reality, the camera is placed at infinite distance. Okay, we are showing camera is placed here, but in reality, camera is placed at infinite distance in Z direction, Z1 direction. Okay, it is not here. Okay, so it is somewhere in the infinite, like the light direction is at infinite, it is also at infinite. How it make difference? It doesn't make any difference. It is here or here, but in specular calculation, so there are three parts. Ambience part, no difference. Specular part, diffuse part, no difference. Ambience part, no difference. Diffuse part, no difference. But in a specular part, there is a difference. So, now if I see this calculation, a specular of the light, okay. Now, if I have a light source, I think we have this, right? Okay. We have not had it. Okay, so we'll draw it. Now, if I have a okay, so if I have a light source, and this is the surface, so this is the surface and this is the light source, Okay. So this is the light source. This is the surface. Now few things that comes into the picture is normal. If this is the vertex we are talking, normal of the vertex, that is in this direction. Light falls on this direction. And light gets reflected in this direction. Where is our eye? Eye can be somewhere here. Okay. So this is our eye. And this is the reflection. And this is the normal. And this is the light. So if eye is in, so there are two directions. One direction is the light direction. Okay. So one direction is the light direction and other direction is the normal. So both should be in parallel to have the better effect whatsoever. And reflection direction. So eye should be in reflection direction to see the shininess better. So this is only for a specular. We are talking only for a specular. Okay, not for the ambience or diffuse. For a specular, the shininess, the light direction and normal, one calculation. And vertex normal and the eye in another calculation. So these calculations matter for the specular. So now when camera is here, suppose the light model is this model is here and light is coming from the infinite direction from here. If camera is at infinite direction, the shining should be here. Shining should be here. If camera is not at the infinite direction, it is at 0, 0, 0, what we had earlier. Then if light is coming from infinite direction, then shininess, now light is coming from, but this is the camera. So, okay, so shininess would go down. It won't be at that location. So it matters. The idea is it matters. Camera is near or camera is far. It matters. So this is what we are trying to see. Okay. Now we'll see in the chair. Like chair, this is when camera is at infinite and camera is at 0, 0, how it matters. We'll see in the sphere also. I think we can see. So what we would do is, now in the code, we'll change this. So we have perspective right now. So we'll make it ortho. Okay. And we'll have only sphere. And we'll see the difference. So we have a sphere only, and now we'll see how much it is different. So ambient is 0.5, it is very high. So we'll just make it 1. Okay, and it is, now we'll plot the, okay, we'll move it up. This is the default, means camera is at infinite distance in the Z direction. So I can close this and I can open like this. So we can modify the code. Now okay, it should go up. Nothing. Okay, so I think caps was on. So I can try again, and now we'll modify the code. Now, now we will have a local viewer. The camera is local now. So we'll add GL light model. Now it is a local viewer, and local viewer is 1. So camera is now at 0, 0. GL light local viewer 1. So camera is now here at the 0, 0. Okay, we'll see if it really matters. So camera is now, the default is 0. What we are seeing, the output, it is 0. Now we'll make it 1. We'll try again. GL light local viewer is not defined. Okay, so we'll see what it is. GL light model local viewer. Okay, so we'll move it up. Is it different? That is the idea. This is local, and this is camera, it's placed at infinite. So both are, certainly both are different. We can see the spot is down. Here spot is at center. Spot is at center because camera is at infinite distance in Z direction. Camera is near now. So spot is coming down. It will be more prominent if I move up. So it is going down even. It is going up if it is, we can see here, it is always be at center. Okay, so certainly that is up. So this is the change. We can bring chair. So we have chair, I believe. Okay, so chair ambience is 1. Okay, so it is too big. And diffuse purple, the specular is 1. And so ambience will make little less, kind of 0.5. And diffuse is purple. So we'll display chair. Instead of sphere, we want chair. Let's see. Okay, Mr. Chair has come. And this is the local one. So we can move up. We'll keep it right. Now, we'll comment this, the default one. Okay, this is the infinite one. Is there any, okay, we'll move it up. Is there any difference? There is difference. So if camera is infinite distance far, then we can see the specular component. Here we can see the diffuse component. Since camera is down, it sees from the down. So upper part of the chair, the color is coming. If camera is at infinite distance far, it would it is in the direction of the light. So it generates the specular component. Here it is not able to generate the specular component and diffuse component is taking the prominence. That is clearly visible. So this is where camera is near and this is where camera is at infinite. So these are the fundamentals only for specular, not for the ambient and diffuse. So this we have to take care in the calculations. So we saw this in lab local viewer. So we covered this part. Diffuse light direction and not, sorry, in a specular light direction, this is the normal and then S. S is this. So here S is this guy dot this guy one side and this guy normal and I dot this side. Then we add it and we get the S. So in other calculation only the light direction and normal comes into the picture. Here normal and I direction also comes into the picture. So this is specular. So we have covered this ambience part and specular part. So this is what a specular is. So how shininess differs, we'll see more into a specular if time permits. So we'll come back to original. Okay. We may not comment it. We'll make it 0. Both are same. If I make it 0 also, it is same. Okay. Okay. So local viewer we are making as 0. So this is okay. So we'll see. Okay. So both are different. So if I make local viewer as 0 instead of commenting it, so if it is at far distance, so I think it's right. If it is far distance, then we can see if it is far distance, then we can see the specular, and if it is at near, then there is no specular. Diffuse part is prominent. Okay, so we'll move. So we'll comment this because experiment is done, and GL ortho will bring it back now. To perspective. Okay, so in next exercise we'll see another property of light model is called model two side. Okay, I'll bring a coffee mug. Okay, so I don't know how big it is. So I have coffee mug. So I have one dot ob coffee mug dot ob. I'll copy it here, and here we'll have, instead of chair we'll have coffee mug, and we'll have one more guy called coffee mug, and here we'll have coffee mug, and here coffee mug dot op. Now here we'll say if it is chair, very nice. if shape is coffee mug, now we'll show coffee mug, and same thing, diffuse is purple, specular and shininess. Okay, so let's try. Okay, so coffee mug is quite big. I think we can make it smaller. So we'll put a scale, GL scale, F, kind of 0.4. Now we'll see. Okay, so it is I believe too much shininess. So what we can do is we'll decrease the shininess and we'll increase the size also. I think it is too small. So 0.4 to kind of 0.8, and shininess we can do. So specular will make less, kind of 0.2 should be enough. Okay, so we have coffee mug. Or we can just remove the specular will make it 0. It is shining too much. Okay, so this is coffee mug. Now, coffee mug is hollow. If I press X, okay. So the greenish part is the ambience part, but we can see the surface of the cup has same color. This part and inside part, inside of the cup and outside of the cup has same color. Okay, this is what we don't want. We want a kind of a cylinder. This is a cylinder. We want a cylindrical shape where outside color would be different and inside color would be different. Here outside and inside both are same. So we don't want this. We want different. So the calculation would be that the outside of the cup. Okay. So outside so when we go for the coloring kind of it bounces on the normal. We have to have a normal. When light falls on the normal, when light falls on the vector, on a vertex, then it sees the normal. So in this, normals are provided for the outside also, for the inside also. So inside, if I remove the normal, we don't produce the normal at all, then it would come as ambience. Okay, even though light is falling inside, light is falling outside, both side light is falling. But if I don't put the normal inside, only normal calculation only for outside, then inside would be ambience. Then we can go for light model, some kind of attribute enabling, and where normal is not there, it would generate its own normal, and then we'll have different color. So that is the idea. Okay, so like the idea is we'll go for two side. Now two side means like this is this is a glass. Outside we can see different color and inside we can see different color. Like typically if there is no normal, then inside is ambience. Okay. So if there is no normal and if I set light model two side, then wherever there is no normal, normal calculation is absent, there we can specify a color. So that is the idea of this light model two side. Okay, so I have a cylinder. So we'll copy OpenGL cylinder here. Now in our code, so we'll kind of import the cylinder. So we'll say just import OpenGL cylinder. Import OpenGL cylinder. Now instead of coffee mug, we'll have cylinder. So cylinder we want to show now. And I think coffee mug story is over. So we can just remove this coffee mug. And here instead of coffee mug, we'll have cylinder. We'll just say cylinder dot cylinder. So OpenGL cylinder is a module. Inside that cylinder is a function. We'll just call and say, okay, just do your magic, and then we'll see what's happening behind the scene. Okay, so we can see something. Okay, something is coming. Okay, we'll try again. Okay, we see black. Now I'll show the light. It is caps. Okay, light is there, light has come, and I'll rotate it. It looks like a glass, we can see. Okay, and ambience, it looks like a, sorry. Okay, I'll reinitialize it. Okay, so this is our light source. Press tab. Okay, it looks like a glass. Now, this is, okay, nothing can be seen. Okay, so light gone up. I'll bring it down. Okay, I can rotate the light. Okay, so whatever light we are seeing, that is the bottom one. Okay, otherwise there is no, even though light is available, there is no light. Okay, whatever light we are seeing there. So this is a kind of two surface. There is a one front surface and there is no light. So there is front surface and there is inside surface. Whatever we are seeing, that is the ambience color. So I can change the ambience to see it nicely. So like in light model, okay, or I can add ambience. So light model. Okay, wait. So we'll add a few property now, like 2, 3, 4. Okay. So front ambience, so we'll make it kind of blue. So ambience is blue and diffuse component. So front diffuse is purple, a specular is 1, it's okay. Shininess is there. So this is what it is. So we'll show it again. Okay, so this is ambience. This is what I was saying. Now outside is purple, but inside there is no color because ambience we have set it blue. It's ambience, it's not no color. There is no color. Whatever color we are seeing, that is the outside. Okay. What about coloring inside? So if I change this ambience, that color would change. That is only, so I can make ambience black also. It is up to me. So there won't be any color at all. This is the ambience. There is absolutely nothing. Okay. What about getting the inside color? Like in the coffee mug we saw, inside color was also same as outside color. But here inside there is no vertex. Sorry, there is no normal. So since there is no normal, it will go to ambience part. So in OpenGL we can set something like this. GL light model local wear, light model two side, light model two side, and two side is 1. Now wherever there is no normal, OpenGL would calculate its own normal, that it would be the reverse of the whatever normal we are providing, and it would come as back. So we can set back color. So in the back color we'll set diffuse and specular. So we'll say back color kind of yellow, and specular will set 0. Now we have so a specular is 1. So we'll copy this line, and for the back it is 0. Okay, so diffuse is yellow back, GL back, and specular is nothing, no shining. Okay, now front. Now we'll bring it back. Is there any magic? Okay. Okay, inside should be yellow, but it's not yellow, it is white. Okay, so we are happily changing the cone. So we have to change cylinder. So it will come here. Okay. Sorry. Okay, so idea is that we should have changed. So back will get back here and back here. Okay, so we have to change the cylinder. We modified the cone attribute. So in cylinder, now back diffuse is yellow and back specular is nothing. So diffuse front is purple. Okay. Okay, we have set ambience as black, so it doesn't matter. No. Oh, what a glass it is. It is really, really nice. So, this is Mr. OpenGL. I can show the light. Okay, so light source is here. Okay, I can rotate the light. Light is very near. I think we can move the light near little far. So light is coming towards camera. Okay. So it is really nice. Now it is better. Okay. And we can see, we can rotate the glass. So this is how it is. Okay. So now in the absence of normal, we can see that we have set the, if I see the program, if I see the ambience is black. Now even if I make ambience kind of blue, it won't be blue. It is yellow only if I run again. So this is because we have done magic in the, we have set the variable called model 2 side. If it is model 2 side is set 1, wherever there is no normal calculation, there we can set back diffuse, back specular, and that would come into the picture. Okay. So this is the calculation. Okay. For this ambience, okay. So specular is black. So we can see the black specular where it should actually shine. And here it outside specular is white. Okay. Specular is white, shininess. Inside, the specular is black. Now we'll change it. Now the global ambience is RGB, is blue. So I am going to comment this and we'll run another one. Okay. So this is without 2 side, and this is something that we don't like because we cannot set shininess or whatsoever. Okay. And this is what we want. Okay. So this is about the light model 2 side. Okay, now we will focus on the material emission. So material emission. Okay, so the material emission. A material should emit a light, like we have light source, and light source is always bright. This is what we are saying. The light source is always bright. Okay, so light source is always bright. What about light source changing the color of a material? It doesn't depend upon the light source. It means it should behave as a light source. It should look like a light source. Like it doesn't look like a light source. If I decrease the light also, it will get illuminated in same intensity. What about illuminating the light source? Like this cube is just placed there. Cube doesn't change its light. What about changing of a material, its emission? So we'll try to kind of emulate a situation like light source color would change. If light source color is dim, then it should throw less light, and light source color is bright, it should show more light. Okay, so emission property is the color of the material, irrespective of the light color. It should have its own color. That color should propagate. It should behave like a light source. Okay, it cannot be that bright, and it cannot emit light, but it should glow, and it should glow less. It should glow more. So this would kind of bring a model of any street light or any lamp uh, or any bulb, so, or star or sun or moon, so that we can kind of simulate with this light emission. So that we'll see. Okay, so for the now we'll bring back our code to some previous situation. Okay, so we'll have, for now being, we'll have two light model, two side for time being, and then we have not made much change, so things should remain the way it is. Okay, so for the emission property, so what we need to change, that we'll see. So we'll bring a, okay, so now if we see our program, then we have a kind of when we draw the cube, we disable the lighting. We won't disable the lighting. We re-enable the lighting. We won't re-enable the lighting. Okay. And cube display, so this color fundamental will go away, and now we'll have ambient equal to 0 and emission equal to emission scale. So now it would be guided by some external parameter. Diffuse equal to 0 okay. So means we can see that there is no diffuse at all. If there is no diffuse, means we are not dependent upon the light source. Specular is also 0. Okay, so there is no meaning of shininess now. So this is a kind of a dumb cube. The cube doesn't receive light at all. Specular 0, diffuse 0, gone. Now it has its own shininess, and that shininess will kind of we will control through another property called emission scale G. Ambience also we are setting 0. So everything is 0. Okay, now we have one parameter here, cube scale. Now we will have another one called emission scale G equal to 0. And in the keyboard function will another key. Okay, so like here 2yy. So if it is a light cube and if we have S, so we are adding one parameter called S, and S would increase or decrease. So capital S. So here we will say emission scale, okay, will increase by 1 or by 2, and here we decrease by 2, emission scale. So emission scale will increase by 0.2 if it is S, otherwise will decrease by 0.2. So that is the idea. Okay. Now, so here we have to add one more guy because we are changing it. Emission scale. Now in the cylinder, the cylinder diffuse. So cylinder front diffuse is 1. Instead of 1, we'll say it is emission scale underscore 0, 0. This is emission, this is always 0. This is emission scale 0, 1. Okay. So this is how diffuse is. So back diffuse is yellow. So we'll also change emission scale 0, 0. Emission scale 1. Okay. Specular is so shininess we are keeping as it is, or we can also change it. Emission scale 0, 0. Emission scale 1. Emission scale 2. Okay. So I think we are done with the modification. Now we'll see what it is. So we'll close this and we'll execute it. Okay. Now it is dark. It can be seen. It is dark. And if I bring light, it is black. I can make it bigger. It is black. Okay. Now if I press capital S, light should grow. It is growing. Okay. Light should grow for the light source also. That is not happening the way we are thinking. Okay, so in the light source, GL scale. Okay, so emission equal to emission scale. I think there is no emission here in the OpenGL utility. So when we draw in OpenGL utility, we have not set emission. So we can change it here, or we can add there. So probably I can change it here. So GL, or we can add it there. It is same thing. So we'll add it here. Okay. So we won't set emission property here because there is nothing to take care in the library. It's missing. So we can say GL material FV, GL front, GL emission, and that would be emission scale. Okay. So now we'll try again. Okay. So we have now I can see the light that is black. Now if I increase the light emission, now I can rotate it and I can, so this is the glass. Now if I increase the light, we can see the light source. I mean the cube. The way cube light is growing, this light is growing. Okay, specular is too high. Okay, so I think the emission property is too high, so we can change this here again. Okay, so emission property is getting set everywhere, so we don't want emission here in the cylinder. So we'll set the emission 0. Okay, so lighting model is kind of it requires practice. It's not that straightforward. So I'll set emission as 0. I don't want emission property in cylinder, so deliberately we are setting at 0. Now we can try again. So I'll show the light and it is bigger, right side will shift it and will increase the light. So I'll move this. Okay, there is nothing. So as light is glowing, there light is coming. If I decrease the light, so it looks like this is real light source. You see the cube. Okay, so I'll bring it to default location. Okay, now I'll bring it cube near, so it will be, and will transfer it. Just see the now the light falling at this glass is exactly same as what it is at cube. So if cube light is decreasing, it is really behaving like a light source. Okay. It is really behaving like a light source. Yeah, I can decrease the light. Now only ambience is there. I can increase the light. Ambience of outside is blue and inside it is coming as black. Okay. So okay, I can decrease. No lighting, there is no light. Increase. Okay, so this is emission property. So we talked here. I have a tree also that also glows like this. So that we can see, but this is what we saw now. So vertex calculation, emission of the material, that matters. Ambience we saw. Diffuse and specular more we'll see. Okay. Now we'll see spotlight effect. Okay. So I have a tree. So what we can do is I'll bring it back, this emission. Okay. Okay. Two side is there. Okay. Now I think or we can just leave it, and I have a tree. So instead of cylinder I can show a tree, and tree will be like this. Tree.obj. Okay. And we'll have now, okay, so we can close this chapter of lighting, or I can show once on tree also this lighting. I think two side is not required in the lighting of the tree, and here it will be like this only, and here instead of a sphere, cylinder, or I can say it is a tree. I mean, I am not going to, or I can just copy paste. It is up to me. So like if L shape equal to tree. Okay. What we want in the tree. So in the tree, so what property we want in the tree? Okay, so we'll copy paste this code 3, 4, 5, 6, 7, 8, 9. Okay, I think tree will come under shape, so this we can copy. Shared or display. No, it will be tree dot display. Okay, so ambience of the tree will make it blue, kind of 0.5, it is blue. Diffuse component is green because a tree will keep a specular as green. Okay, diffuse component is green, RG1. Okay, and okay, tree doesn't shine, so there is no meaning of shininess. So specular is green, diffuse is green, and ambience is 0.5, that is blue, and this is the tree. I think we have not touched Mr. Cylinder. Okay, and this is the exactly. Now we can have a tree now. This is tree, and tree we have initialized with tree dot object. We'll copy tree. There is a tree dot object here. We'll try again. Okay, I think tree is big. We can make it small. So I can place GL scale. So I'll say GL scale kind of 0.4. Okay, so it is float. Oh, our tree is ready. Okay, and it is green. And idea is that if I bring the okay, and if I increase the light, okay, and it become white, so we don't want that. So we'll set GL emission as 0 here also. So we don't want emission here. So GL emission is 0, and we have enabled both side. So back side also it would do the magic. So that we don't want. Okay, so it is disabled. Okay, nice. Now we'll try again. Okay, now I can increase the light. Okay, tree light is green. It is not changing, but we want from. So we'll add heat here. Now in the tree. Okay, so tree ambience is blue, that we are not able to see. Now diffuse, we'll say emission scale G1, and here also emission scale underscore G1 probably will multiply by 0.5. We'll try again. Oh, so this is a blue tree, and tree is blue because it is only ambience. Now we have the light source that is black. You cannot see. I shall increase the light. Okay. Okay, so it's pretty clear now. So I can decrease the light, I can move it up, the light source. Calculation is big because it is a big object file, and I can decrease the light. Lights, both only ambience is there. I can increase the light. Okay, so I think comprehensively we have a finished emission material. So we have finished light emission and ambience, diffuse and specular. So this will show now. Okay, so this is what we have finished. If emission of the light source we can set depend upon our keyboard, and if it increases, the light at the tree is increasing. Now we'll have a kind of a diffuse and a specular. So I think we have covered many times diffuse and specular. Then we'll go for great cutoff. So diffuse and specular will bring a sphere again. Okay, and okay, we'll end up this drama of lighting emission. So lighting source will bring back our original code, and this is we don't want now. Okay, so light will appear at its best, or we'll leave it as it is. I think we need to change a lot of code. So we have to press the lighting. Okay, we leave it as it is, or we have to. Okay, in the cutoff, I don't think we need to change it. Okay, so we'll remove. So we have to remove really good amount of code. I think where and cube scale, and here we'll remove this area. Okay, this. So now we don't want this. Okay, and here in the keyboard we'll remove this line emission completely. Okay, so source code is changed now, and now we'll focus emission scale. Okay, so cylinder emission scale. So cylinder is 1. Wherever emission scale is there, will replace by 1. Okay. Okay, so Mr. Animation is gone. Now we are at the old code, and we'll bring the here instead of tree we'll bring a sphere. So sphere, we are trying to show, so we'll see what is a sphere right now, because we have changed the source code so many times here and there. Okay, so sphere looks nice. Okay, so we'll set the diffuse specular as 0, and we'll see how a sphere looks. Okay, so this is the sphere. This sphere has diffuse property, but it doesn't have specular property. So this is the actual color, like this. The sphere has no shininess. So this is the called okay. It has no shininess. We can increase lighting or something like that, whatever we want. Okay, so this is diffuse is there is no shininess. So for shininess we need to have a specular component. Now it will bring the shininess. Okay. Okay, so shininess has come. So this is about diffuse. So this is in our lab session, that diffuse and specular. And in the specular we have shininess. We can increase the shininess, we can decrease the shininess. So now shininess we are seeing what it is. So we can increase the shininess. So shininess is 40. If I increase shininess 80, it would shine more. Okay. I can really see what it is. So this is 80. And this is 4. Oh, sorry, this is 80. We can keep 10. I think then it would be more prominent. So difference between 10 and 80 of the shininess. No one stops us to move the camera. So shininess also moves. Here also we can move the lighting. Okay, so shininess is part of a specular. So in the calculation of the vertex, shininess comes into the picture. Shininess comes into the picture, and that is the S. So that is in the specular we have to think about the camera location also. So I think comprehensively we have covered this. Camera location and the specular. Now we have seen specular and diffuse part. Okay. Now we'll see attenuation and spotlight. So light, if I place the light away from the material, then light should be dim. That is the idea. Okay. So we'll have another component now here, that is called attenuation. So we'll set attenuation. I think we can switch it off. Okay, so we'll have another guy called attenuation, GL light model. Okay, so I think this is not we want. So we'll set kind of GL light F, GL light 0 and GL linear attenuation as 1. So for the light source 0, GL linear attenuation we are setting to 1. So in this formula, this is the constant one, this is linear, and this is the quadratic. So linear one also, if it is 1 and it is anyway 1, so it will decrease half if I move the light. So we'll see if it really happens, attenuation. So light should decrease, the idea is. Okay. Now this is our light source as white. So we will bring near to the camera and we will see a sphere. Okay, I can make the sphere big. Solid cone radius 0.5. I can make it 1.0. Okay, I change something else. Okay, so solid cone I change 0.5. I have to change this. So I'll make it 1.0. And I'll see if really light has effect. Okay, I can see the light that is appearing. Now I'll bring it near. If light is decreasing, okay, I cannot see the light at all. So what I can do now is, and I can see the light, I'll move it in this direction. And then I'll move it near to the camera. Nothing is moving. Okay, this is the appearing. Okay. Now I'll move near to the camera. Idea is light should decrease. Okay. So it is not decreasing. Okay. So what is the problem? So idea is that our light source is directional light source. This is what we are using. So we'll make it positional. So in the code, if I press P, so if I see the code in the keyboard, if I press P, then I change from positional to directional. So for the directional, there is no change because light source is anyway, it is at infinite distance. So I can move it like this. I'll change it to positional. This is positional. And if I move near to the camera, it should be dim. It is really becoming dim. If I bring near to the material, it is brighter. Okay. I can change the solid to look more prominent to bring back its original size. Okay. And then the attenuation, I'll make it kind of 2. Now we have the, okay. Now we'll bring it to positional. This is positional and it is really changing. I can bring, it is better. And if I bring far near to the camera, okay. So this is attenuation. If light is near, if light is directional, no change. if I bring it near to the no change. But if light is positional, certainly there is a change. Okay, so it is more prominent. So this is how it is. So attenuation makes effect. I can try in tree model. So instead of a sphere, probably it would be better. Tree model, and in tree model I'll keep attenuation 1 only, and in tree model let me see the properties. Okay, and diffuse. Okay, nice. So let's try what is there in time. Okay, so tree is appearing, and this is our light source, and this is positional. Now I'll near. I think light is decreasing. It is prominent. Now if I bring the light near to the tree, light should increase. Okay, it is increasing. Okay, if I bring near to the camera, since we have rotated the axis, it is going somewhere. So it is decreasing clearly. Okay, this is directional light. This is positional. Now if I bring near to the tree, it should glow more. Okay, so change is there. So this is the attenuation. Okay, so now V angle. So attenuation comes into spotlight. So spotlight, so exponent and attenuation property is global. Now we'll see the spotlight. Okay, so this is attenuation. So we don't want attenuation now. Okay, what makes the spotlight? So for the spotlight we should have property like GL light F, GL light 0, GL spot direction. So by default direction is in 0, 0, -1 direction. Anyway, if I don't set also, it would be like this. GL spot cutoff. So cutoff will make at 20 degree. So I think we have. So this is cutoff. Now the spotlight means light would behave like a torch, and this angle is 20. So 20 plus 20, this complete angle is 40 degree. That is what we are setting. Okay. So exponent we won't show now, and let's see it makes difference. So these would work in the positional light, not in the prominent in the directional one. Okay. Okay, GL light 0, GL spot direction, wrong type. (26). So this should be a vector. Okay, so now I'm pressing positional. Oh, gone. So this is cut off. This is a torch now. I can show the light. So this is a torch now. Okay, it reset. Now it is a torch. Okay, so only a part we can see, not the tree. When it comes to the 20-degree cutoff, then only we can see. Okay. So this is spotlight. Only part we can see. So okay. So this is cutoff. If I increase the cutoff angle, so light will be more. Initially it is ambience what it is. Okay, so we have seen the cutoff, how cutoff work. We have another property called exponent. So in the cutoff, like I have a plate where I can show the cutoff light, but it's the spotlight like a real torch where in the middle it would be more brighter and even it is more brighter. So this is called exponent. We can set exponent also in the light. So for the exponent, I think light source property. Okay. The way it is, so we'll bring, it would not be prominent here. So I have a file called plate.obj. So we'll add plate.obj here. So instead of tree, now we'll work on plate. Okay. Now I have another guy called plate. 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 Okay. For the plate, now we'll add one more component called exponent. Exponent is 20 right now that we are seeing, or probably less, kind of 2 DL spot exponent, and in the plate we'll see, and for that the light source will make it 1. So diffuse, specular diffuse is 1, and material will change. So we have another guy called, now we have tree, now one more will come, equal to plate. Okay, I think plate would be big here also, so we'll scale it to 0.4 something like that, and it should not emit anything, and it would be like this only, tree display. So we will have plate display, ambience set to something, diffuse will make it purple the way the lab session is. Okay, and specular will make it 0. Okay, so we have diffuse as purple, and let's see how it throws the light. Okay, so there is a plate. I think plate is still bigger. Okay, so I think we can make it a little small. Probably 3 would work. Okay, so this is our plate, and I can show the light source, and I can rotate the plate. Okay, I'll throw the positional light now, that is a spotlight. Okay, this is positional, this is directional light. This is directional light. This is positional light. Okay, so this is positional light. Okay, so I can remove this cap, this light. Okay, so this is exponent. I mean, this is cutoff light with exponent 2. Oh, nice. Now, I can set exponent as 40 or 20, 40, let's see. Okay, so we can rotate the plate. Okay, now I can make it positional light as. Okay, it's really different. Okay, I cannot, it would, I think it will re-initialize the stuff. So there also we'll see. So it re-initialized everything. Okay, so here we'll I don't know where I am. I think I can do it again. Okay, so now we have exponent as 40. So this is 40 exponent. Okay, I'll make light position. So this is a torch, and at the center of the torch we can see the actual, I can move it more. Okay, so on a plate we are focusing the torch. Now I'll change the exponent and make it less, probably 8. Okay, so I have rotated and I'll make the light positional. So not only cutoff matters, exponent also matters. See, there is a change. It really looks like a focused. So like if I have a torch in my hand and torch is now emitting light, so here it is not kind of focused, it is more focused. So this is the kind of exponent in the cutoff we get. Okay, so we'll see this point. Now we are discussing about cutoff. So we discussed, so in our lab session, we had that light must fall on the vertices, and in pyramid. So in cutoff, we'll see that what is the situation. So we have, so we can don't have exponent here, and just we have cutoff at 20, okay, or we can leave the exponent to 8, and now we'll have this as so we'll make it pyramid. Let's see what's going on. Oh, so we have pyramid, and now this is the light. So we'll bring the light, this is cutoff 20. So I'll make it positional, gone. Okay, again we'll show. So vertex must receive the light. Now I'll show the camera. I'll show the light source, and this is directional. We'll make it positional. Let's press P. Okay, so light is at vertex where it is blue. I'll move it up. Gone. Light must fall on the vertex. If I move up, it will be red. If I move down, gone completely, because vertex it is not receiving the light. I'll move left, so green is getting. I'll move right, again green is getting. Okay, nothing. So what I can do is I can remove this cut. Now it is not a cut, so it's not a spotlight. Now I'll bring the light source, I'll move it up, I'll make it positional. It's there. So vertexes are receiving light to some extent, but if I make it a spotlight, since light is coming in a kind of beam, vertexes are not receiving what they should. So this is light source, I'm moving it up. Now I'm making it positional, gone. So this is a kind of in vertex, I think it is called Gorward shade model. In a smooth shade model, vertex must receive. So later we'll see that in Phong model, when we see the shaders programming, it's possible to have lighting on pixel wise rather than only vertex. But right now in the fixed function pipelining in Gorward light model, so this is the scenario. Now I can rotate. The way vertexes are receiving the light, it is showing. Okay, I can rotate in this fashion also. If I come back to calculation of the vertex, so we have covered emission of the material, ambience, attenuation, spotlight effect, spotlight, and then exponent. Then we have taken care of the light model ambience and the light source, and then diffuse, and then specular, and in that shininess. Okay, so we started with light philosophy, and then we saw like all the attributes of light. like color emission and shade model, and then light model, and then diffuse specular, and then spotlight. If you are looking for Kiwi or machine learning training, or you are looking for Kiwi and machine learning application development, or you are looking for porting your QTQML application to Kiwi, or you are looking for 3D OpenGL application development, you can contact us. You can also sponsor our videos. Please do contact.